So the first example, we're going to use a substitution method. And we have the system with the equation quantity of x minus 2 squared plus the quantity of y plus 3 squared equals 4, which I called that equation 1. And then equation 2 is negative 7 minus y equals negative x. So the first thing is, let's think about what these equations are representing, because they're not going to be just lines for all equations. We're going to have different graphs. So if I think about this, remember I reminded you what that equation of a circle is. We have an x squared, a y squared, and something squared. So therefore, this is going to be a circle when we graph it. And then our second equation, both our y and our x are raised to the first power. So this is going to be a line. Now let's think about the different possibilities of how these two graphs, a circle and a line, could intersect and how many solutions that would give us. So let's think about this. If we have a circle and then we also have a line on our coordinate plane, well, we could have it where the circle and the line don't even cross. And so in this case, we would have no points of intersection because they don't share any points, so we would have no solution. Well, what if we had a circle and our line just barely touched our circle, so it was a tangent line? Well, in that case, we're going to have one solution because there is one point of intersection. And our last possibility is if we had a circle and our line actually was like a chord and crossed at 2 points with our circle. And so then in that case, we're going to have two solutions. All right, so let's go ahead and solve this system. So first step is we're going to solve one of the equations for one of the variables in terms of the other. So I'm going to choose to solve for x, and I'm going to solve for x in our equation 2 because it's actually going to be really nice because x is pretty much isolated. We just have one step. So our equation that we currently have is negative 7 minus y equals negative x. Well, x is by itself, but the only problem is it's negative x. So in order to make this positive, I'm going to multiply by a negative 1 on both sides. When we do negative 1 times negative x, we now have our positive x. On the left-hand side, make sure you distribute. So negative 1 times negative 7, we get positive 7. And negative 1 times the negative y, we get positive y. So here is our new equation. Now, moving on to step 2, we're told to substitute the expression from step 1, so this expression 7 plus y, into the other equation, which is our circle equation, for our value of x. So we have x minus 2 squared plus y plus 3 squared equals 4. Well, now we know what x is equivalent to, and that's 7 plus y, so I'm going to plug that in. All right, so now if you look at this equation, we got rid of all of our x's. We are only left with y's and constants. So now, step 3, we're going to solve this equation here for our variable that's left, which is y. So we're going to solve for y. And so I'm just going to continue my work down here. So the next thing that I can do is, remember, we need to work with parentheses first. In this first set of parentheses, we have some like terms that we can combine, which is 7 and negative 2. So when we combine those, 7 and negative 2 is a positive 5. So in our parentheses, we have y plus 5. That's squared. And then the rest of our equation. All right, another key algebraic property that we need to remember, and we talked about earlier in the semester, remember that we have this expression y plus 5, and the whole thing is being squared. So that means that we have y plus 5 times a y plus 5. Just like with our y plus 3, since that's being squared, we have y plus 3 times y plus 3. So now we need to distribute and multiply all of our terms in our parentheses. So we have y times y, which is y squared. 5 times y is 5y. Y times 5 is 5y. And then 5 times 5 is 25. And then same thing with our second set of parentheses. So we have y times y is y squared plus 3y plus 3y plus 9. All right, so now we need to combine our like terms. So here we have a y squared term, and there's another y squared term. So that's 2y squareds. And then our y terms, so we have a positive 5y, positive 5y, positive 3y, another positive 3y. So adding those together, we get, there's 10y, 13y, 16y. And then our constants, we have 25 plus 9, which is going to be 34, and then equals 4. So now we're trying to solve for y, and I see that I have a trinomial that is equal to a constant. So I'm going to have to factor. But before I can factor, I need to make this right-hand side equal 0. So I'm going to subtract 4 from both sides. And we get 2y squared plus 16y. 34 minus 4 is 30 equals 0. So now we can factor. I'm going to use the trial and error method of factoring, but one thing that will make this a lot easier is that if our coefficient of our y squared term is 1, and right now it's 2, and my other coefficients in my trinomial are also divisible by 2. So first thing I'm going to do is factor out that greatest common factor of 2. So we're going to have 2 times the quantity of y squared plus 8y plus 15 equals 0. So now I can factor what's in my parentheses. So I'm going to need 2 factors because it is a second degree polynomial in there. And I need to get y squared, so I'm multiplying a y times a y. These numbers, whatever they may be, have to multiply to be 15 and sum to be 8. And so that's going to be 3 and 5. We have a positive 8, so in order to get positive 8, these both need to be plus. All right, so now we're solving for y. In order for this equation to be true, either y plus 3 has to give us 0, or y plus 5 has to be equal to 0. So solving for y, we get y equals negative 3, and we have y equals negative 5. So here are 2 values that we have found for y. And now we're going to go ahead and find our values for x. So I'm going to use that equation that I found in step 1. So there's 7 plus y equals x. And I'm going to take turns plugging in the 2 values that we found for y. So first one was y equals negative 3. So substituting in negative 3 for y. 7 plus negative 3 is positive 4. And then if we have y equals negative 5 instead, we have 7 plus negative 5, which is going to equal 2. All right. So now we have two proposed solutions. So our x-coordinate is going to be 4 when we plugged in a negative 3 for y. And then our x-coordinate is 2 when we plugged in a negative 5 for y. So here are our proposed solutions. Our last step is checking them. So let's go ahead, and I'm going to go ahead and check our 2, negative 5 point. And so in the first equation we had was x minus 2 squared plus y plus 3 squared equals 4. And now we're going to substitute in our values for x and y. So x is 2. And y we found was negative 5. And now we're checking, does this in fact equal 4? So remember, you're not working with that right-hand side at all. You're leaving the 4 alone and then simplifying our left-hand side to see, do we get the same thing? Well, 2 minus 2 is 0. And then in our parentheses here, we have negative 5 plus 3, which is a negative 2, still being squared. 0 squared is 0. And then negative 2 squared is a positive 4. So we do, in fact, get 4. Our second equation was negative 7 minus y equals negative x. Again, substituting in our 2 for x and our negative 5 for y. And here we have, negative 7 minus a negative 5. Well, minus a negative 5, that's going to become a positive 5. So negative 7 plus 5 is, in fact, negative 2. So that solution makes both of our equations true. We have one more point to check, which is 4, negative 3, which I encourage you to check that algebraically, just like I've done with 2, negative 5. But we could also graph it and check it that way. And so here I have our first equation, which is our circle here in purple, and then our second equation, which is our line, which I have plotted as a dashed line. If you click on Desmos, if you click on the graphs, it'll actually tell you your points of intersection. So 4, negative 3 is in fact a shared point, as is 2, negative 5, which is exactly what we got here. All right.